Hey everyone, Mike Settele here to give you another deeper look at the answer to this question. How does SAT scoring work? What is each question worth? How does the worth of a question turn into your score out of 800? Specifically, we are going to talk about the twists and turns in the SAT scoring system. I have a much shorter video on the basics of how the SAT scoring works. Definitely watch that. For most people, that's all you need to watch. It gives you all the strategies, all the things that you need to know to work through practice tests and understand how the number you get right determines your score. I am not going to go into any new strategies here. This is just for people who are super curious about how it works, but I promise you, I am not giving out any new information that is going to affect how you approach the SAT. This is purely so that I can stop answering the same comments over and over and over again on my channel. The basics video has everything you need. The link to it is in the description. And I will warn you from the start, this is not a particularly well-polished video. This is going to get very, very complicated, especially if you are not someone who enjoys math in any way. And I barely understand this math myself. I am a smart man, but this is just way beyond my field of expertise. So hopefully the basics video is enough, but just in case, let's get into it and talk about the twists of the SAT scoring system. This is what you should have seen if you watched the basics video, and just to kind of recap it very quickly, my big conclusion from that video is that each SAT question is worth roughly 10 or 20 points. The big thing here, though, is that is an estimate only. The scoring is actually much more complicated, as we will see. But even still, even though I said it was an estimate and emphasized that, within minutes of me posting that video, there were lots of comments saying, yeah, but I got one question wrong on the math and it brought me down to a 770, so it's actually worth 30 points. Yeah, estimate, guys, estimate, read before you all freak out. And so that's the thing. If you are looking for some sort of like certainty in this scoring system, you're going to be very disappointed by the time this video ends. So just buckle up here. Let's talk about one big exception that I did not talk about in the other video to this estimate that each question is worth 10 or 20 points. And yes, maybe 30, but a lot of questions are going to be worth 0 points, okay? These are the pre-test questions. So what does that even mean? The SAT is testing out new questions before they go live on actual tests. So on every SAT, there are going to be 2 pre-test questions per module. These are what we used to call the experimental questions. They do not count for your score. They are worth 0 points. I know that for a fact. That is not part of the estimate. They are worth 0 points. So they will not affect your score if you get them wrong. This is also true on the practice tests. So there will be times where you get something wrong and you still get a perfect score if it is one of those pre-test questions. And so that means every practice test, every real SAT is actually only 90 real questions plus the 8 pre-test questions, 2 per module. So 2 in each of the reading modules, 2 in each of the math modules. That's 8 total, leaving us with 90 real questions. And those 8, we don't know where they are. They're anywhere in the section. They could be at the beginning, they could be at the end, they're in the middle probably. Who knows, okay? We cannot predict where these questions are going to appear, and they're not going to look any different from normal questions. And that's because they are pre-test questions. Before these questions appear on a real test, they are on your actual SAT exam. And basically what they're doing is they're collecting data on these questions to determine how difficult they are, whether they're good questions or not. And so they're going to look like real questions because eventually they will be on real exams. So I've heard tutors say, and maybe I've said it before too, who knows, that if you are taking a test and you get a question that just seems kind of weird, it might be a pre-test question, and so you can just ignore it. But again, that's not really true because these are questions that will appear later. So they are, in every sense of like the style, SAT questions. They just don't count for the scoring yet because they haven't been finalized. So I guess the advice still holds though. If something is weird, don't worry about it too much, move on. Because remember from the other video, the basics video, our main strategies are, number 1, get as many questions right as possible. And 2, don't leave any questions blank. So if something is really, really weird to you, it doesn't matter whether it's a pre-test question or not. It doesn't matter what you think, whether you think it counts or not. What matters is, are you going to spend the time trying to get it right if you don't really understand it? Your goal is to get as many questions right as possible. So you got to keep moving. You got to move on to questions that you do understand. But still, if you think something is weird, if you don't know how to answer it, don't leave it blank. put an answer, even if it's a random guess. You want to make sure you're answering every single question, but you also want to make sure you're not spending too much time on any single question. So hopefully that all makes sense. This is a clear exception. If you are curious in the Blue Book practice tests, which ones are the pre-test questions, just go to my website. I'll put a link to my testing page from my website in the description. And I've kind of highlighted the ones that we know are pre-test questions. And so that way, if you do get something wrong and you're curious if it hurt your score or not, you can kind of see. But I don't think this really matters. It's not a huge number of questions, and the advice still holds. Get as many questions right as possible. If some of them happen to be pre-test questions, no big deal. You're moving through the section to maximize correct answers. Now let's move on to the more complicated stuff, okay? Hopefully, you've seen a curve like this at some point in your life. This is a normal distribution curve. And when we talk about a test, a standardized test, it means that the test has to do with this curve. The curve is basically where the scoring system comes from. So the SAT is a standardized test because the SAT is based around this curve. And so we can put the SAT scores on the different kind of markers for the normal distribution curve. If you take a statistics class, you'll see this. It's not really on the SAT in terms of a topic, but there are other things related to this that are. So you can see, though, that I'm kind of estimating, the data isn't perfect in real life, but I made it simple just for the sake of explanation. 500 is an average score. It's the middle of that curve, okay? Then on either side, every 100 is kind of roughly an increment along this curve. So you can see it goes all the way to 800. It goes, if we continued past the 400, we'd have a 300 and a 200. And that is the scale for one section of the SAT, is from 200 to 800. Can't get better than 800, can't get worse than 200. Though in real life, a normal distribution curve goes on forever in both directions. For the sake of simplicity, we don't have any way to go beyond 800 or below 200, so we'll just cut things off there. But it doesn't matter anyway, because there's not much going on beyond 800, even in a normal distribution curve outside of the SAT. Now, another way of understanding your SAT scores is the percentiles, which I also talked briefly about in the video for the basics of scoring. And your percentiles do appear on your SAT score report. So you will see those when you get your SAT scores back. Most people ignore them because it's just like this kind of side number. And it's really that number out of 800 that most people are asking about, talking about, putting on their college applications. But the percentiles are a way of understanding how those 800 numbers fit into the overall distribution of people taking this test. And so we can see the 500 that's right in the middle is the 50th percentile, meaning that 50% of people do worse than 500, 50% of people do better than 500. I'm oversimplifying a little bit, but that's to make the point. This is enough of an understanding to understand how the SAT works. And as we go along this curve, we can see there's different percentiles going all the way up to 99 plus, which means not quite 100, but pretty darn close to it. Now, a statistician might also understand that the percentiles, the SAT scores, fall along certain markers where we think about standard deviation. So if you are studying for the SAT, you do need to know generally what standard deviation is. It is a measurement of the spread of the data. We're never going to have questions like the stuff I'm about to talk about on the SAT, but you should understand that standard deviation is a way of understanding how far away you are from the middle. So the 600 score is a +1 standard deviation, meaning it's a little bit above average. The 0 is our 500, is our average score, and -1, we go on both sides, is a little bit less than average. So you can see the curve is highest in the middle, right? Which is basically what I was saying. Most people are somewhere between slightly below average and slightly above average. And then you get to like +2, the 700s, right? That's 2 standard deviations above the middle, and that's more rare. So there's not a lot of people there. And then +3, that's also way out there. So you can see the curve kind of leveling out as it works its way out there. Another way to understand what's going on with SAT scores is to recognize that normal distribution is very common in real life. There are lots of applications of this. A very common example is something like the height of adult men. Okay, so let's kind of put SAT scores and male heights in the same kind of category here to better understand both. So this is some data I found. The average height of adult men is 5 feet 10 inches. So that's the 500, okay? That's the middle. That's the 0 standard deviation, right? Smack in the middle. The standard deviation of adult male height is plus or minus 3 inches. So 3 inches on either side. So someone who's slightly below average height is going to have a height of 5'7". That's kind of like the 400 level. And then someone who's slightly above average is 6'1" is going to be kind of like the 600 level. And most people, by far, are going to be somewhere between 5'7" and 6'1". So if you're in that range, you are not special. Most people, most adult men in the world are very similar height to you. But if we move 2 standard deviations, right, to that 700 level, that plus 2 standard deviation, right, that's when an adult male would be 6'4". And that's not an outrageous height, but if I saw someone 6'4", that's a little tall, right? I would think that that person is tall, and it's kind of a little freaky standing next to them, maybe, because there's not many people that are going to be that much taller. I'm 6 foot, by the way, and so that's unusual. But then if we go plus 3, right, to the 800 level of height, 6'7", that's insane, right? That's an NBA player. That's a freak show. There are very, very few people, very few adult men who are 6'7". That is a rare height to be. And if we think about percentiles, right, that's a 99th percentile height, meaning someone who's 6'7" is taller than 99% of adult men. So hopefully that also puts in perspective how hard it is to get an 800 on the SAT. You have to be better than 99% of people. That is very difficult to do. So every time you're out in the world and you're seeing someone who's 6'7", that's the frequency of people getting an 800 on the SAT, roughly. Okay, so I've only met maybe like 3 people ever in my life who are 6'7" or taller. So it is a very, very rare thing. Now, this data isn't perfect, like I said, but it is a great way of understanding how the scoring kind of starts out for the SAT. But let's take a little closer look. Going back to the SAT, we'll try to understand it with some raw numbers. Let's focus up on those 500 scorers, okay? Another way to think about it in terms of beyond percentiles is that there are, and this is true roughly, that there are approximately 2 million people who take the SAT every year, okay? 2 million. So if you score a 500 in one of the subjects, you're the 50th percentile, which means that you are better than about 1 million people. So congrats, that's good for you. That's pretty great. Now, of course, there's 1 million people who are better than you, but hey, you got to start somewhere. So that's not so bad. Now, if we increase our score, right? We study, we work hard, we get to a 600. All right, what does that mean? Well, now we're going to move into the 80th percentile. We are now going to add another 600,000 people that we have just surpassed, that we are now better than, leaving 400,000 left over, which seems odd though, right? Because if we think about like the way the spacing of these things works, it looks like the right side of that graph is 3 sections, right? Thirds. And we moved up a third. And yet, in terms of the raw numbers, right, we moved up more than half. 600,000 is more than half of the 1 million people who we're trying to beat. And that's because, again, the height of the curve represents how many people are at that level. So moving from 500 to 600, you're surpassing a lot of people. But there's a lot of people in that zone. If we continue and get another 100 points on our SAT, and we get to a 700, we're going to pass another 300,000 people. So there's still 100,000 people who are better than us, okay? But notice there's a couple of weird things that have happened, right? Before we moved up 100 points and we got better than 600,000 people. Here we moved up another 100 points, but now it's only half that. It's only 300,000 people that we've moved past. Another way to think about it, right, is the percentiles. When we were at the 50th percentile, right, we were smack in the middle. Then we got to 600. We moved up 30 percentage points, right, to the 80th percentile. But then another 100 points, it wasn't another 30, right? That's not even possible. It was another 15, right? So it seems like 100 points on the SAT isn't worth the same thing. And it is, but the point is that people are distributed along that scoring scale unevenly. So when you get closer and closer to 800, there's fewer and fewer people who are in that scoring band as well. So if you're in the middle, there's lots of people in the middle. But as you get to the end, it gets harder and harder. And this brings us back to that 899 plus. you will see this in the percentile charts that the SAT releases. I'll put a link to one in this description. That means that we are not just at the 99th percentile, we are past it. We are at like 99.8th percentile. There's very few people who are getting those 770s, 780s, 790s. The difference in terms of raw numbers of people between a 750 and a 780 is very, very small. Because as you can see, it's just 100,000 people who are basically getting from 700 to 800. And that's, again, I've oversimplified the data a little bit. The actual number is slightly different. I will share it just in case you're curious. According to the 2024 data that I found, which is actually the last year of the previous version of the SAT, the actual number of people getting between a 700 and 800 was about 150,000 for reading and 175,000 for math. And the middle isn't perfect either. It's not like 500 is exactly the 50th percentile in real life. And that has to do with who takes the test and, whose scores improve, because the SAT scoring kind of does shift a little bit towards the top end. Because think about it, if you're getting a 300 in the reading section, are you really going to keep taking the SAT and trying to improve? I think that might be where you could just kind of quit. And so the numbers start to skew away from those 200 and 300 level scores. So it does skew up. But again, this is really a great way of thinking about where you stand. Your score is a nice number to think about and to tell people, but it's those percentiles that matter. And it's those standard deviation numbers that are really helping us put things in perspective about how rare our score is. So if you take a statistics class, we'd probably call those standard deviations something different. They might be called z-scores, and that's just the word they use. And it has to do with how far away you are from the middle. So for the next piece of this scoring thing, we're going to talk more about z-scores. In fact, we're going to flip things. We're going to stop really thinking about the SAT score out of 800 as our score, because what the SAT is really doing is it's assigning you a z-score first, and then it is calculating, or it is adjusting that z-score to the score out of 800. So when we do all the math in the back end to figure out your SAT score, before you're out of 800, you're something close to 0, right? So let's flip things around and give you another curve. Okay, so what is this? Where is this coming from? This is one question on the SAT. Okay, this is what one question looks like to the computer that's calculating scores. It looks like this. And so another way to look at it is with this particular equation. And I told you there'd be some crazy math. So this is, if you want to bail now, I totally understand. But we're not going to actually calculate anything. I'll do all that for you. But let's talk about what this equation means, because it's insane, but it's determining your score. So the P is kind of like our Y, right? It's function notation. So as you see in the graph, right, the y-axis is the probability that you're going to get that particular question correct. Okay, so you can see that it goes up and down depending on where we are on the x-axis. And the equation is using the z-score as the x value. So in other words, what is going on in this graph is that it is showing us for every particular z-score, for every particular skill level, there is a percentage chance that someone answering this particular question is going to get it right, right? So that's the P of Z part. Then we have all these other letters, the A, B, C, and E. And the A, B, and the C are the ones that really determine the personality of a question. So each question has a completely distinct set of A's, B's, and C's. Okay, the A represents the quality of the question, the B represents the difficulty, and the C kind of represents the guessing probability for the question. All right, so we'll talk more about each one. The A, B, and C values are determined by those pre-test questions. I think this is where I'm starting to get kind of lost because I don't understand the math super well, but also because the College Board has not released specific details about how this works, but they have shared this equation. And this equation is fundamental to that idea at the top. Item response theory. This is how the SAT is built. It is not just a normal test. It is built on a theory that is proven with math that makes it so we have a more accurate test that understands scoring and skill levels better. So the A, B, and C are going to be determined when thousands of people answer those pre-test questions that don't count for their score. The College Board is still collecting all sorts of data from those questions, And they're basically doing a regression, which if you're doing some advanced stuff in Desmos on the SAT, you might be doing yourself, a much simpler version. But they're taking all those data points, they're trying to find a curve that fits them, and then they're finding the values of A, B, and C based on that. E is a number. It's like pi. It's a specific number. So that's not a variable. And you can see in the exponent there is buried our Z, our skill level. So let's talk about all of these numbers in more detail. The A is the quality of the question. And this is the one I actually understand the least. Basically, the A determines how steep that curve is. And the steeper the curve, the better the question is at determining someone's skill level. I don't really get that one that much, but I will say that from what I've read, the A values of like 1.5 are going to be pretty good. So I would imagine the College Board is getting rid of any questions that have very low A values, have very low quality in terms of ability to tell different students apart. And so they're getting rid of those and they're keeping the good ones. And that's what's on your test. So for all the examples I'm about to use, I just made A a constant of 1.5. But I do believe that on the actual SAT, since different questions are going to have different data to build the question and build the equation, there would be different A values. The C value, skipping B for a second, the C value represents the guessing constant, let's say. And for that, I'm going to make all of our examples 0.25. And that's because most questions in the SAT are multiple choice from 4 answers. So the chance of you guessing randomly and getting it right is 0.25. And you can kind of see that on the curve, right? Go all the way to the left. And you can see that that curve hits the y-axis at around 25%. And that's because even someone who's very, very low skill, whose Z-score is -2, -3, very low skill, is still going to have a 25% chance of guessing correctly on a question. Okay, so that's basically the floor. Now, not every question on the SAT is going to be multiple choice. And plus, I think that this is not set in stone, even for the multiple choice questions. Again, I don't understand the math very well, but this we're going to keep constant for simplicity's sake. It's the B value that is most interesting because that's how we determine the real way that the question is going to change. So this example here is an average question, dead on, straight in the middle, B equals 0. Okay, and we can see, right, that dot there is at the 0 point for the x-axis, the z-scores. And you can also kind of see that the point, the dot, is kind of where this thing kind of hinges, right, where it changes. As we get closer to the dot from the left side, we're kind of starting to accelerate, right? It's getting steeper and steeper. But then once we hit the dot, it kind of starts to slow down and go the other way until it levels off at the top. And that's that basic shape is gonna get preserved no matter how difficult the question is. But you can kind of define a question by its difficulty, but it doesn't necessarily mean, or it doesn't mean that everyone who's of that skill level is going to get that question right. So let me be really clear, right? This is a 0 skill or an average level, perfectly average question. And if we look at the 0 on the x-axis and go up to that dot, where is the dot? It's at about 62%. It's technically 62.5%. So what that means is if you took a perfectly average student and gave them this perfectly average question, they would have a 62.5% chance of getting it right. Okay? So if they were above average student, then they'd have a higher chance. We can see the curve is going up on the left. If they were below average student, they'd have a lower chance of getting it right. So it depends on the skill level, and the curve is telling us the chance that someone is going to get it right. So you can see all the way to the right, an 800 level student has basically a 100% chance of getting this average level question right. But let's put it another way so we can all understand the math as clearly as possible. Instead of thinking about one student, let's take 1,000. 1,000 level 0, perfectly average students, right? 0 is our average, right? It goes negative, so 0 is our average. If we took 1,000 of those students and gave them this particular question, this average level question, we would expect 625 of them to get it right? 62.5%. So 625 would get it right, 375 would get it wrong. So even an average level question, not every average level student is going to get that right. Okay, so hopefully that makes sense. We're going to change the difficulty though. So let's clear this out for a sec. And then let's think about a hard question. So this is what a hard question is going to look like. and it has a b-value of 1.2. Okay, you can see the whole graph is kind of shifted. But I do want to point out that when we work on SAT practice questions, they are labeled in the question bank as easy, medium, or hard, right? There's 3 possibilities. But in the scoring system, as far as I know, there's infinite possibilities because the value of B can be in between things. So it's not like an easy question is a -1 and a hard question is a +1. We even know from experience that hard questions, there's some questions that are hard, and then there's some questions that are really, really hard, right? Probably those like 2.1 level questions, things like that. So this 1.2 is definitely harder. Things have shifted, but in terms of our understanding, it's still working by the same basic rules. So if we took 1,000 students who were all at skill level 1.2 and gave them the 1.2 level question, we'd have 625 right answers and 375 wrong answers on average, right? So you can see the dot from the average question and the hard question are at the same spot because we held the A and the C constant. So it's shifting left and right, but that middle point of our curve for each question is going to basically be the same. It's going to be roughly the same, and it's defining kind of like a middle spot based on the skill level. So the difficulty of the question corresponds to kind of a difficulty or a skill level for a particular student. But if we think about that same hard question and we go back to our 1,000 level 0 students, now what happens? Now we got to find where the 0 hits that pink curve. And if we go up to that point, we realize that our average students are going to struggle on a hard question. Makes sense. Only 356 of them are expected to get it right. And way more, 644, are expected to get it wrong. So that is how a question is determining what's going on. It's going to change the probabilities of what kinds of students are going to get it right and wrong. So harder questions for an average student will be harder to get right. And you can see too, like all the way to the left there, right? Below average students are also going to have a tough time. But even on the hard question, all the way to the left, it hits that y-axis at 25% because if it's a multiple choice question, that's kind of as low as it can go. You still have a chance of randomly guessing from the 4 answers and getting it right. So we have this kind of like flattening of the curve on both ends. Let's change things up again. Let's still focus on our 1,000 level 0 students, our average, perfectly average students, but let's give them an easy question. This one has a difficulty or a B value of -1.6, right? So that means it's kind of geared towards the people who have a skill level of -1.6. But in an SAT, you're going to have lots of different difficulty questions, so everyone's answering a little bit of everything. Now, if we gave this easy question to 1,000 average students, we can see where that curve hits the 0, right? There's 938 of those 1,000 students would be expected to get this question right, and just 62 would be expected to get it wrong. So this is kind of why the test is adaptive, right? That number doesn't really tell us much because most, by far, average students are getting this question right. And if we move a little bit to the right, if we go to the +1, the 600 level students, notice that the curve is not that much higher. And if we go to the +2 students, we basically hit the top, right? There's going to be like 2 kids who get this wrong. So why would we give the high-skilled students easy questions? It wouldn't make sense. It'd be a waste of their time, and it wouldn't tell us anything about those people's skill level because for an easy question, an average student and a +3 student and a +2 student all kind of look the same. And that's why the SAT is going to have a wide variety of difficulties so that we can, over multiple questions, kind of figure out where everyone is. And that's why, too, the test got shorter when they made it adaptive, is they were able to remove questions that didn't matter. Once you get placed in that hard module, they know that those easy questions weren't going to tell them any new information. And so why bother giving you more easy questions? We're going to focus on medium and hard questions that have a better ability to discriminate between a +1 student and a +2 student. So yes, this is confusing. We're almost done. We're getting there. The point is an SAT is made up of dozens of these curves, right? Each question has its unique personality. It has a unique set of A's, B's, and C's, and it's telling us different probabilities based on different people's skill levels. So you've got dozens of these curves for every SAT. So how do we take all these individual questions and get a single score? Well, we're going to talk about it. So this is our starting point is we have one question that follows this particular general equation. But then, right, there's a bunch of these on each test. Specifically, there are 50 of them in reading, 40 of them in math, right? We removed the pretest questions. So there's 50 questions that count in reading, 40 questions that count in math. And that means there's 50 of that equation in reading, 40 of that equation in math. And what they're doing for each subject is they're taking all those equations and they are combining them into a mega equation. And I'm not going to bother writing it because it involves calculus and statistics that, again, I don't really understand. But I understand the concept, okay? They're making a mega equation. And that mega equation is still basically doing what the individual questions did. It is helping us understand the probabilities based on the skill levels. But here's the thing. When you take an SAT, it stops being about probabilities as soon as you submit your answers, right? When you do a hard question, it's not like you have a 30% chance of getting it right once you've picked an answer. It's either right or it is wrong. The die is cast. So we can't understand your skill level based on probabilities because you have taken the test. You have right and wrong answers. And what's happening here is we're going to convert all those right answers basically into zeros and ones, because a 0 is 0% chance you got it right because you got it wrong. And a 1 is 100% chance you got it right because you got it right, right? So then this is where a lot of people get confused about how the SAT scoring system works, because our instinct is, okay, I've got my zeros and ones for my right and wrong answers. Let me just add them up, right? Let me add up all those ones, and that gives me a score of some kind, right? And that's actually how the old SAT used to work before it was adaptive, is you would literally take a practice test in a book and add up all the answers that you got right, and you get, let's say, a number like 43, and then you go to a table later in the book and you say, okay, 43 is my raw score, and that means a 690, right? And that's literally how it worked. Every question was worth the same. But now we know they're not worth the same because each question has its own unique equation, its own unique B value at least, right? So we have average questions, we have hard questions, we have easy ones. So, okay, this particular one might be the easy question. This particular one might be the average question that you got right. And so what we have here basically is proof that the number 1 doesn't always equal the number 1. These ones are not necessarily equal to each other. Same thing with the zeros, right? You might have gotten a hard question wrong. That's going to behave differently. So then again, a lot of people are going to ask a question that doesn't really make sense in the context of item response theory. They're like, okay, well, how much is the easy one worth? How much is the average one worth? We're going to add those up and that'll get me my score. No, the mega equation is never individually looking at your right and wrong answers. It's always looking at the list. It's always looking at the whole collection of right and wrong answers. And it's doing some complicated math. Again, I barely understand it, but it's doing a lot of math, doing a lot of calculus. And we put all of the question equations into the mega equation. We put all of your right and wrong answers into the mega equation. And basically what it spits out is a list of Z's and P's. Right? So Z's, remember, that's our Z scores. That's your skill levels. And the P's are the probabilities. So what it's basically doing is it's running the equation a bunch of times, and it's saying, okay, for each of these particular Z scores that we think, or this equation is judging and saying, okay, the probability that someone with this particular Z score would get those particular answers, the ones that you put, is whatever probability, right? So, okay, the probability that someone with a 0 Z score, a perfectly average skill level, would get this particular set of right and wrong answers is, I don't know, let's say 13%. Then the probability that someone with a Z score of, 1.1 would get this particular set of answers is, I don't know, 22%, right? I don't know the numbers, But that's basically what it's doing. And it's doing it for every single possible value of Z. And it's getting a probability. And then what it's doing is it's saying, okay, what's the highest probability? Whatever the most likely situation is, whatever the skill level is that is most likely to produce your particular combination of right and wrong answers, that's your Z-score. That's your skill level. It is using probabilities to try to understand your answers. Again, it's always about the collection of answers, but it is finding the most likely skill level that corresponds to your right and wrong answers. And then once that's done, I think this is the point where it returns to the old ways. I would bet that somewhere in a computer or whatever, there's basically a table where this particular Z-score gives you a particular SAT score. Maybe at some point the SAT will release that, but most of this is a lot of speculation because I don't know what's going on beyond just how item response theory works generally. So this is confusing, but it just goes to show there's a lot that's going into your score. It is not as simple as just counting up right and wrong answers. This mega equation is doing very complicated math, but it is trying to find the most likely skill level for you based on the hard, easy, medium questions that you are getting right and wrong. Plus, there's one more complication. You have two modules. It's an adaptive test. So what's happening here? They're actually running this mega equation twice. You get your first module, right? The one that's got a lot of easy, a lot of hard, and a lot of medium, right? It's about as even and average as you can get for a module. They're getting your answers to that first module. They're putting them in the mega equation, and they're getting a first guess as to your skill level. If that skill level is high enough, if that Z-score is high enough, they're going to put you in the hard module because they know that if we keep giving you easy questions, we're not going to learn anything else. So we're going to give you the hard questions so we can refine your skill level, your Z-score. Same thing happens the other way. If they do that first run of the equation and your skill level is too low, they're not going to waste your time with hard questions that they already know you're going to get wrong, right? The probability, they know you're not going to get it right. So they're going to give you easier questions. And either way, your score can be, somewhere in that kind of big middle of the distribution curve. That kind of 450 to 650 is kind of a zone where a lot of people are going to fall no matter which module they get placed in. But after they've made that decision for you of which module you get placed in, now when they finally calculate the score, they're going to take all those questions that you've done. So the first module ones and now the second module ones, and now they can get a really accurate, supposedly, estimation of your Z-score because now they have twice as much data, right? They have twice as many answers. And that second go round, that second module, they were being really precise with what they asked you. So remember, the test is not adaptive from question to question. It's always it's that one point where they take the module one stuff and throw it in the mega equation to get an estimate. And that's the only point where the test is adapting to you. But it's still adapting and it is still trying to estimate your skill level based on your right and wrong answers. So going back to the basics video, what are we supposed to do with all this information? What does this mean for how I take the test? Well, like I said at the beginning, I'm not changing my story here. The strategy is the same as it was when we didn't understand any of how item response theory worked. You got to get as many questions right as possible, and you don't want to leave any questions blank. So this, as we saw, the equation is complicated. So when people ask, should I target the easy question? Should I go after the hard ones first because they're worth more? Again, the equation is not looking at individual questions. It is looking at the collection of data and making a guess as to your skill level based on all of that. So if you're getting a lot of easy questions wrong, what do you think it's going to think about your skill level? Probably not very highly of it. And so that's why your goal is not to target easy, medium, hard. I guess it is. It's to just get as many questions right as possible. So that means getting those easy and medium ones right and convincing it that you are at that skill level at least. That is the better than getting a bunch of easy ones wrong. And we don't want to leave any questions blank either, because the more data we give it, the better it's going to be, supposedly, at figuring out what kinds of things we've got. And I honestly don't know how it handles blanks. I don't know if it treats it as a wrong answer or if it kind of ignores the data. So I have no idea. Maybe the College Board will tell us at some point, or maybe they have and I just didn't find it, but I don't know. But I still believe that if you leave a question blank, you are guaranteeing a wrong answer, or at least if you guess, you've got a chance. And for the most part, we're not guessing completely randomly. We at least know one or two answers are probably not right, and we're able to guess from that. And this gets to another question that I don't want to get into because this is, oh my God, this is so long already. But is there a guessing penalty on the SAT? I will make a separate video about this, talking about it. The short answer is no. But basically, people do think that, like, all right, if I guess randomly on stuff, it's going to hurt my score. And the College Board's own website says things that can be misinterpreted to make you think that. So again, I'll make a separate video on it, but the quick version is, it's not about guessing randomly on hard questions. It's not like you're penalized for that necessarily. What's happening is, if you got a bunch of easy, low skill questions wrong, and then you get a high skill, high Z-score question right, the mega equation is kind of judging you. And it's like, wait a minute, they don't have the skill to get these easy ones right. So knowing that there's a 25% chance that they might be guessing randomly and getting this hard question right, that is all getting worked into that mega equation. And so maybe you're not quite getting enough or as many points, or however you want to think of it, getting enough credit, getting enough skill points for those hard answers. So my only thing with that is, you probably just don't want to get easy questions wrong, because then it's going to, the mega equation is going to think less of you. So that just gets back to what is at the top here. Get as many questions right as possible. That is how you make your score higher. Whew. So normally at the ends of these videos, I say, please comment with any questions, but I doubt I will be able to answer them because we are literally at the end of my understanding of this. The statistics are complex. I hope that I hit the main points correctly. Like I said, at various points, I was kind of estimating some numbers and simplifying things just so we could get the main point across. But I do think I got the key ideas of how this SAT is scored out. If you are a statistician or an expert in this field and I missed some big item response theory piece of information, then please put that in the comments and I'll highlight it. But I think my conclusion from all of this is, there is no gaming the system. There is no secret super strategy that is going to mean that you go from a 600 to a 750. You have to do the work. You have to learn the strategies, learn the topics, memorize vocabulary words. You've got to practice. That is how you increase your skill level. And then that increase in your skill level will be reflected in more right answers and right answers on harder questions that will convince that mega equation that you are deserving of a particular score. Because remember, yes, the SAT is out of 800, but as we saw, it's really out of the normal distribution curve. It's about standard deviations. It's about Z-scores. And so you're always kind of trying to figure out where you are in that curve. And being in the middle is easy. Lots of people are in the middle, and that's not bad. But getting towards the end gets harder and harder. So you're going to need to actually do the work. There is no guessing strategy or anything that is going to get you those last points. Hopefully this helped, and hopefully, like I said, you have no more questions. But please get to studying, and when you do it, use my channel, like and subscribe. I've got tons of lessons that are way, way easier to understand than this scoring system. So hopefully you agree. Yeah, definitely like and subscribe. As always, I'm Mike Settele. When it comes to your scores, don't settle for less. Settele for more. Thanks for watching.